gold exploration in covered terrains, insights from the Western African Craton. Before going ahead with today's session, little bit about housekeeping. All attendees are on mute and are requested to keep on mute. If you have any questions, please enter it in the chat box. If you are experiencing any technical glitch, please try exiting and rejoining the webinar. Little bit about DataCode. DataCode is a leading organization in the field of geoscience industries, bringing cutting-edge technology and services to the industry, especially to the growing Indian market for more than now 25 years. We believe in mantra of 3 E's, which is empowerment of end users, enhancement of employment skill sets, and equity of all stakeholders. Little bit about this session on Partner in Progress. It is a theme initiated with an objective to bring eminent speakers of geoscience domain and share their knowledge to the community. The sessions were designed with an intention to empower students and professionals from the industry and thereby creating a wealth of knowledge for the society at large. It is open for all students, professionals, and they all should attend and grab knowledge out of it. In line to that, today we have Devarajan sir with us, who is going to give a talk on his experiences in gold exploration in covered terrains, particularly with reference to the Western African Craton. Mr. Devarajan commenced his professional career in 1989 with the Geological Survey of India. He joined the Australian Indian Resources, Bangalore, as an exploration manager in 2006. He led the resource drilling of the Jonagiri Gold Project and participated in the pre-feasibility studies for this project, including the preparation of the NI 43-101 report. Between 2019 to 22 February, Devarajan sir headed the Mineral Services Division of Geological Services in Kolkata. In this capacity, he carried out a resource drilling program for gold project in Tanzania. Devarajan sir is currently the Vice President of Exploration in Supreme Gold Corporation, an exploration company with its registered office in Toronto, engaged in developing gold projects in West Africa. He holds a PhD from IIT Bombay and is an active member of OSIAM, Geological Society of India, Society of Economic Geologists, and Mining Engineers Association of India as RCP. So without any delay, over to you, sir, for today's talk. And you can share your screen.
Thank you, Dhruv. And also a great thanks to DataCode for suggesting this topic and giving an opportunity to talk about gold exploration in covered terrains. For most of us from India, exploration in covered terrains, especially laterite covered terrains, is not new. And but compared to the type of laterite cover which we see over the Greenstone belts in India, the type of extensive laterite cover which you see in Western Africa over the Birimian gold belts is enormous. So today's my topic is essentially to highlight the risk or the challenges which are involved when we use the conventional exploration tools for exploration in such covered terrains, especially in the West African Craton. So for the benefit of those who are relatively new to the geology and tectonics of the West African Craton, I have shown here a couple of diagrams. On the left, you have a geological map of the West African Craton that includes two shield areas, the Archean shield area of Leeuwman Shield, which covers essentially the countries of Sierra Leone, Guinea, Liberia, and Cote d'Ivoire, as well as the northern Reguiabat Shield, which is which covers Mauritania and Algeria. And I have also shown a small political map of Western Africa. The central part, the red colored area, is Mali, where I am currently located. And surrounding Mali, you have Senegal and Guinea to the west, Sierra Leone to the southwest, Liberia and Ivory Coast to the south, and Ghana to the southeast, and Burkina Faso in the eastern side, and Mauritania and Algeria on the north. Now, as I mentioned, the two cratons are actually covered by the younger sediments. The yellow color in the central part is essentially the Neoproterozoic, Mesozoic, Paleozoic to Mesozoic, even Cenozoic sedimentary cover, which starts with the sedimentary basin known as the Taudani Basin. And the topic of interest for today's discussion is the southern side, where you can see a lot of greenstone belts are shown, which is the Birimian belt, the prolific gold-bearing area of the Birimian belt. And I hope you are able to see a lot of yellow, white-colored circles there, which are the gold mines, active gold mines, about which we'll be discussing in detail. So before we go into the exploration in Birimian gold belt, let us try to understand briefly about the geomorphology of the West African Craton. So here there are two slides. On the left side, I have shown the major river systems and a generalized digital elevation model. You can see that some of the rivers like Niger, they originate very close to the Atlantic Ocean on the western side in Guinea or Sierra Leone, and flows to the opposite direction, almost like the peninsular Indian system, where the rivers flow towards southeast. So they flow towards opposite direction, almost 1,300 kilometers, and then take a right turn and come back to the Atlantic Ocean near Nigeria. And this is reflected, this is essentially due to a major topographic break very near to the west coast, which is known as the Guinean Rise. And vast areas in the central part of West African Craton is a terrain which is about 400 meters average elevation. And just like the Okavango Delta, which is in the southern part of African continent, Niger also has a delta on a continental delta in its in Mali. And coming to the slide, which is on the eastern side, there is a red colored patch in the western part, which is the prolific bauxite bearing areas, starting from very near to Conakry in Guinea to all the way up to Bamako for about nearly 700 kilometers. So these are essentially the relict high-level landscape, bauxite landscape. And then there is an intermediate relief landscape, which is shown in the purple color. And the southern areas are the dissected part of the topography. And the northern part is the lowest, more or less what we call as the pediment or pediplain. Pediplain is a coalescent pediment area. So this is essentially the topography. And this also, if you look at from a cross section, you can see that these bauxite bearing areas are the highest erosional remnants. There was a famous geomorphologist, a South African geomorphologist named Lester C. King. Most of us might have studied about his work in the university. And he had identified a very old geomorphic planation surface in his scientific contributions, which he made in the 1940s, and which he had called as the African surface. So this African surface is about Cretaceous age, and It is dissected by stepwise dissection over since Cretaceous, and now appears as erosional remnants or depositional features at relatively lower levels and relatively of younger age up to um, Holocene. So if you look at the higher elevation areas, the bauxite bearing areas, the residual weathered profile will be immediately underlined by a bedrock. Whereas if you come to the lower areas, the laterite is actually has two different profiles, two different genetic segments. The upper part of the lateritic profile is transported laterite, and below that there is a residual in situ laterite, and then comes the bedrock. So this is at the lower level of the topography. We have what we call as regolith, is essentially a transported laterite, which is the part of the pediment, and below that is the actual residual bauxite. This is something which makes the laterite profiles of West African Craton different from most of the laterite profiles in India, especially in places like Central India. Now, coming to the gold protection in West Africa, we have the Birmian, it's the central part, which is the largest Paleoproterozoic gold producing region in the world. And during the last decade, from 2011 to 2020, this area has produced consistently more than 200 tons of gold. The latest available figures show that in 2020, 322 tons of gold was produced. And this was mostly from countries like Ghana, which topped the list. In fact, 2020 production was even more, about 140 tons. Followed by Burkina Faso, about 93.4 tons, Mali, 93.8 tons, Guinea, 56 tons, Ivory Coast, 41, Senegal, 14 tons. So these production is actually coming from some of the major mines like Lolo in Mali, which is located in somewhere here, and then Tarkwa in Ghana, located here, Essakane in Burkina Faso, Fekola again in Mali, somewhere here, and then Akim, Akhafo, Hundi. So these are the number of mines which are actually shown here. Coming to the geology of this area, again, the Paleoproterozoic greenstone belts, which occur along northeast southwest, dominantly along northeast southwest linear belts, and bound by major ductile shear zones. They are the host of the orogenic style of gold mineralization. So essentially produced during the strong crustal shortening event, which has happened in Paleoproterozoic around 2.1 giga. And the strong structural control is very much evident in most of the deposits on a regional scale as well as at the mine scale. In addition to this, there are also a number of placer deposits, placers on the current rivers, present rivers, and also paleo-placer deposits. The paleo-placer, when I say the paleo-placer, I mean the placers which are occurring in the lateritized domains, as well as in the geological older domains. In fact, there is a paleoplacer, even a Paleoproterozoic paleoplacer deposit within this domain. Now, to understand the geology a bit, I have shown the Birimian belt of Ghana here. And here they describe traditionally the greenstone belts as belts and basins, where the belt is the term normally given to that part of the greenstone belt where the volcanic dominant sequences are observed, which includes essentially tholeiitic basalts and a bit of andesitic basalts, andesitic rocks, and with a less amount of sedimentary rocks. The sediments are mostly carbonaceous phyllite wherever present. So these are the belts, and these are intervened by large tracts of sedimentary sequences with very little volcanic component, and mostly gravacase, phyllites, quartz vacase. So essentially a turbidite type of sequence. And overlaying this, in the southeastern part of Ghana, there is another sequence, which is a completely sedimentary sequence, starting with a conglomerate and then further going into quartzites and phyllites, which is known as Tharkawa. Tharkawa also has gold mineralization. Some of the mines are located in that. And except Tharkawa, these belts and basins are actually included by a group of granitic rocks. And some of these are syntectonic intrusive bodies with well-developed foliation in it. They are called as, and some of them are not late tectonic intrusives with not much of significant foliation. So for those who are listening to this from the Indian, those who are from India, those who are familiarized with Mahakoshal and other belts, especially Mahakoshal, just recall that the Paleoproterozoic of India, especially the Mahakoshal, has almost like a similar stratigraphy, about which I'll be discussing maybe next month in another forum organized by the Gondwana Geological Society. And these rocks have been undergone deformation by northwest southeast crustal shortening, as I mentioned earlier. And the major event of deformation and granitic emplacement has happened around 2.1 gigaannum, which is known as the Eburnean orogeny. And many places have been subjected to metamorphism up to amphibolite fishes, but generally it is the greenstone fishes metamorphism which is dominant in most areas. So that gives us the general idea about the geological background. And coming to the exploration, here I have just shown just one country, which is Mali, where the entire Birimian belt is actually occupied by applications, active applications for gold. Similarly, there are 349 active licenses for gold exploration in Mali alone. And similarly, the other countries also have a large number of active licenses. Many of them are owned by Australian companies, Canadian companies, British companies. So this is an area where they have a very good system of cadastre portals where you can identify areas which are available, like in the most well-managed jurisdictions for exploration. And a lot of companies are actively producing and mining and producing and exploring gold in this West African Craton. So coming to the tools which are used by these companies, if you go through their reports, whether it is NI 43-1 or JOG, whatever the reports they have produced, their technical reports and company releases, you can see that they have used the tools which are normally familiar with many gold exploration geologists, including the geochemistry tools like stream sediment sampling, soil sampling, termite mounts. This is an additional advantage which we have here, that the areas which are not disturbed by agricultural work, there will be numerous termite mounts which can be used while carrying out soil sampling. And the geophysical tools used include gravimetric surveys and in some cases IP surveys. And in some countries like Mali, the government has already conducted a large-scale aeromagnetic survey of the entire Birimian belt, which is available for the exploration companies. And coming to the field geology, the companies have used techniques such as trenching or mapping of the artisanal sites, updating of the geology. In fact, the geological maps which are available are essentially largely interpreted geological maps. Some of the licenses, the concessions which are taken up by companies have practically no outcrops. So the geological map is essentially inferred on the basis of whatever limited outcrops available. So this has to be kept in mind while looking at the, you know, uh, the rock types which are shown on the maps, as well as the contacts between the different rock types as shown in those maps. And drilling is now carried out by auger, by RAB, by AirCore, by RC, and by DDH. So these are the ways the companies are creating their exploration data and looking for targets. Now, coming to the some of these tools and where exactly the problems could come up. Conventionally, we use stream sediment sampling. The conventional wisdom is look for anomalies in stream sediment, either by chemical analysis or by panning, and look for the target areas on the upstream. That is the conventional wisdom. So when you go up, you may see the laterite like this, which are mined by the artisanal workers, and you may get, if you collect these samples from the laterite profile and look for gold, you may get gold as shown here in this pan. And soil sampling also is essentially done along with the termite mounds. And again, our conventional wisdom is that weathering or the soil forming process concentrates some metals like iron, aluminum, nickel, copper, gold, and manganese. And there is a secondary dispersion produced around the primary ore, which we can delineate in the soil sample process and look for target areas. But does it really work well when we have transported laterite? This is something which we need to understand in the context of carrying out exploration using these tools in West Africa. This is because, as I had mentioned earlier, the geomorphologically, we have these high land, like high glacis terrains, and then the very gently sloping ground in which part of the upper part could be erosional, but in the lower parts, there could be the transported pediment, which is now lateritized. And so the profile may have, the laterite profile may have a significant component of transported laterite as shown here. So this transported laterite could have been transported as part of maybe as an alluvial fan, or it could have been part of a talus or debris flow, whatever the processes which are associated with the slope process, or a combination of slope processes and alluvial fluvial processes would have given rise to the transported component. And so any anomaly which we may come across or we may delineate within the lateritic terrain need not essentially indicate a primary hard rock hosted target just below or just in the provenance areas. This is applicable to both soil anomaly as well as stream sediment anomalies. So here I have taken the liberty of reproducing a map from one of the company reports. On the left side, you can see this company had done extensive soil sampling on a specific grid, and they did in fact get a good anomaly in PPB up to 200 to 2000. And there are two anomalies, rather a number of anomalies a number of anomalous values in between the central area, a cluster of anomalous values on the northern side, a cluster in the southern side. And on the diagram on the right side, you can see that there are black dots, a number of black dots shown, and they have actually chosen to go for RAB drilling. In this case, only those areas where the anomaly is clustered and there is a inferred structural control. So that is the area which they have decided to go for drilling, because this is very important that the anomalies could be actually otherwise, may not have the depth persistence. They may not be linked to deep structural structural reasons. So you will be you will end up with only a paleoplacer type of gold deposit. So here on the right side, I have shown two diagrams. Both are taken from artisanal site. The upper diagram is an artisanal site in Mali, in southern Mali, named Finico, in the Sikasso region. And there you can see a few people are standing there. From that, you can understand that it's quite a deep vertical section. So here, the artisanal mining has progressed from mining the lateritic material to the deep bedrock to considerable extent. And whereas in the lower diagram, you can see that the artisanal activity has not progressed. They try, and then some smaller pockets of laterite was taken out, maybe panned, and gold was recovered, but they did not go deeper. So these are the two cases probably where one has a deep structural connotation. In fact, in the first one, the upper one, there is a phyllite and a carbonaceous phyllite exposed, and that has thin sheeted or stringery quartz veins wherever we could observe, which actually leads or which is gold bearing, and that is probably has become part of the lateritic profile in the first upper diagram, whereas in the lower one it is probably a paleo channel which was actually hosting the gold mineralization, which was removed by the artisanal workers, very in a very targeted manner. So, so essentially now we are actually talking about the structural control which needs to be understood while carrying out the exploration in the laterite terrains like this. As I mentioned earlier, the structural control is very clear from the regional studies to the mine scale to the clusters of mines. So here I have shown the broad structural major shear zones mapped by Chardon for West African Craton in the central part. On the left side, I have shown the Kinieba Inlayer, which is an area of paleoproterozoic rocks of the Birimian in the Senegal-Mali border area, which is normally known as the KKI or Kinieba Inlayer. There is a north-south black line which is shown there, which is the Senegal-Mali shear zone, and that has a number of major gold mines located either along the shear zone or along its splays. There are a couple of papers I have come across where the influence of the shear zone or the structural control they have mentioned that it is not significant, but when you look at this scale, and looking at various other mine scale photographs and cross sections, I could see that there is a significant structural influence. So here there is a shear zone, and a number of mines are located along it. On the left side, there is one mine known as Sabadola that is in Senegal, and here in Mali there are a number of mines along it, including Sadiola. And in the central part, I have shown the mines of Morilla and Sama, which are again here, which are again controlled by major structures. Here, almost north-northeast, south-south trending. And in case of Sama, that is a major thrust, which is east vergent, and it continues up to further into Ivory Coast towards south. And similar observations can be made in Ghana also, where the northern shear zone, northern contact of the Ashanti belt host a number of mines from Obuasi to Prestia and a number of other mines. So the strong structural control is evident at the regional scale, even at the mine scales, which, as I have shown here, from some of the mines which I have just mentioned, Sadiola in the Keniba Inlier area, and Sabadola again from that area. There is a main fault which is actually controlling the mineralization in Sabadola in Senegal. And Morla is a mine which is already now mined out mostly. And here the mineralization is along a thrust plane, and Sama is again along a major thrust. So the structural control at various levels is very clear. And now, how to identify the structures as in your target generation? To me, it looks like ground magnetics can actually help. I have gone through a number of reports produced by various companies. Ground magnetics with proper data collection and processing and filtering and creation of modeling, especially the inversion and other models, it looks like they can definitely pick up the structures. There will be challenges in processing the ground magnetic data because this is a completely laterite terrain. So the noise from the laterite is will be there, but I believe there are now techniques available, the filters available in software like GeoSoft, where it can be processed well, and depth slices can be produced to look beneath the laterite cover and also carry out 3D modeling. And when such data are integrated on a GIS platform, along with the surface geochemistry, the knowledge on the regional structures, the locations of the artisanal sites, and also a more refined digital elevation model, that can actually lead to identification of targets. That is the strategy. I think it seems to be working in the case of some of the companies which have been successful in delineating new targets in a terrain like this. And so I have listed out a series of exploration tools or a sequence which could actually lead to identification of target, as target identification is the most challenging in this type of area, where you have hundreds of square kilometers without even a single outcrop, but underlined by a prolific gold-bearing belt. So one can start with multispectral remote sensing, and this may help or may not help, but when you have the multispectral remote sensing data, and when you study it along with all other data sets, including the structural and the historical data and a proper digital elevation model, perhaps you would be able to identify target zones. And stream sediment sampling and panning definitely will help in identifying gold areas, but this, as well as soil sampling, the anomalies have to be tested to check whether these anomalies are restricted to the upper transported part of the pediment. And that is possible by doing pitting or trenching, and also by ground magnetic survey, and followed by the 3D modeling and inversion of the magnetic data. And as I mentioned earlier, when you integrate all these data sets, the multi-proxy spatial data on a GIS platform, you are likely to define your target if a target exists, which can be initially taken up by auger drilling, because this terrain is quite suitable for auger drilling, and that is the cheapest drilling method available. And one can carry out a number of boreholes in a day, and the target can be very quickly evaluated, and a decision can be taken to go to the next stage, whether to go for RC drilling by that process. And a few RC holes will definitely tell us what lies below even the depth of auger hole. So this is the sequence of exploration program, which I think has been successful or will be successful. So thank you for listening. If there are any questions, let us, if there is an, we can take a few questions. Thank you so much. Thank you, Data Code, KK and Drubu and others for organizing this. And looking forward to hear your comments. Thank you.
Thank you, sir. Thank you for this presentation. If there is any question, please type it in the chat box, or we have unmuted all of you. If there is any question, please raise your hands. Otherwise, we can take a question one by one. In the meantime, Avani sir, if you have anything you want to add on.
I have actually quite a few questions. I don't know. I don't want to take all the time of Devarajan sir. Devarajan sir, given a chance, I'll definitely ask questions. It really is not questions. It's for my learning purposes. Actually, I've not come across many gold occurrences, with lateritic cover. The way I was listening to you, it sounds like the way it sounded like, it's like the gold deposit, but it is covered by laterite. Maybe if I'm trying to summarize what we said, the gold is actually the gold is actually occurring in the hard rock, probably, right? And is covered by laterite. And you said sir, actually the gold can be. Auger drilling is pretty sure. I mean, yeah, I'm trying to relate to the other lateritic deposit like nickel and stuff in South American terrain, and we use a lot of auger, but it's very rare for me. I have not come across and this is probably the first time I'm learning this thing from you. That these presentations, so some of the information in there. So so how deep they go in the auger drilling. But sir, I'm not done yet. I think you can just summarize it. I have a couple of comments. So how did they go to find the hard rock mineralization? Second thing is, if they do that, what kind of mineralogy is that, for the gold? I mean, sir, the way I say it, the gold occurrence in laterite, the minerals that will have gold. Probably not gold telluride, something like that. I don't know. But if you are looking at this is very old Archean type of terrain, we're talking about structural controls. Is it like more sulfide or more, traditional what we see in North American or Indian terrain? More like, is it like the high salt, low salt type of model can fit that there? What kind of gold we're talking about, below the laterite? And to get there, we got to have more mineralogical understanding. I'm comparing that what I'm, there's in North America, particularly Nevada, western, say southern Utah, there are gold exploration going like anything, right? They're crazy. As a result, what has happened, what I'm seeing in this part of the world, there are a lot of basic sciences happening. A lot of basic sciences. That means through various channels, through educational institutions, from directly, basic science commercial institutions or companies now in Vancouver, in various parts of these parts of North America. There are many companies came up. So what that they're doing is they're trying to understand the mineralogy. Is there something happening there too? So sorry, sir. I kind of everything, trying to understand actually what the genetic model of that means. Very interesting.
First of all, Abani, in one of the slides I had mentioned that the Birimian gold mineralization is what we call as the orogenic style gold mineralization. That is a term which was, used by Gross way back in 1988 and 88 or 98, 98, I think. So these are the type of gold mineralization which we see in the orogenic belts like Archean belts and also in the Paleoproterozoic belts like Birimian. So essentially, the gold mineralization is a part of the deformational, or it is related to the orogenic processes which has created or which has closed the original volcano-sedimentary basins, and the mineralization is related to or formed during the deformation and metamorphism and the intrusive phase of the orogenic activity. So that is why their timing is mostly related to the deformational stage of these belts. And that is also indicated from the strong structural control which you see in these deposits. And this area is very extensively studied. Perhaps some of us who are in otherwise working in other continents might not be fully aware of the level of exploration related research which is happening here. There are academic groups based from Australia and universities from Australia and from Europe. These are all part of the earlier French colonies. So from Europe, extensively working in these with very major significant research academic contributions on these belts. And their genetic style, their fluid compositions, their isotopic character, as you have asked, the mineralogy, these are all studied by either by the companies which are working here or by the academic contributors who are working on these countries. So regarding your question about the relative proportion of sulfides, some of them are actually free milling type. Just parts when they just you can by gravity separation itself you can actually separate out bulk of the gold, but there are a few with sulfides as well. But in my understanding, such sulfide-rich deposit are relatively less. Most of them are actually free milling type or mostly of that nature. A number of companies are working. There are a lot of reports available on metallurgy as well on the processing. And regarding your question on auger, yes, auger drilling is now being introduced. In fact, this terrain is almost like Western Australia. So many companies which have succeeded in using these technologies, whether air core or auger, in Western Australian Craton, the laterite covered areas for gold exploration, it is those companies which have brought most of these technologies to Western Africa. So there is a transition of technology from Western Australia to Western Africa. WA to WA is happening.
Very interesting, sir. Thank you. Just the one observation, what I see that most of these companies are from the Canadian and Australian companies. B2 Gold is one of the kind of size company, very popular. I've seen them presenting in PDAC. I'm not in this year PDAC. This year I couldn't go, but very progressive type of company. So I can see Russian companies. I know that Nord Gold has many operations in there, in many countries. In Nord Gold, there are Russians are not very big, but I think that's a kind of exceptional company. I believe, they have many operations in there. You may have heard of them, right? But it's good to know. These are not actually. But I did not know that. My question was, are they really doing the basic science? Because sir,
Yes.
down the road, you need to understand the geomet, right? You need to understand.
Yes. There are very detailed studies on the metallurgy, on the chemistry, are available even in public domain. Mostly generated by the companies, and also the academic contributions are significant. Academic contributions are there.
Thank you, sir.
Thank you, sir. There's one. I think Kashi sir wants to ask something from you. So, Kashi sir, you can unmute yourself.
Yes, Kashi.
Good morning, sir. Happy
morning,
to hear
Kashi.
from you. Happy to hear your lecture after a long time, sir. As usual, it is great. Sir,
Thank you,
you have
Kashi.
shown a sections. They are
Yeah.
really interesting. And the goal, there is a trust related. You mentioned that. I'm only having the book knowledge of that belt. I never worked in that. So is it the case the high grade horseshoes are subhorizontal?
Kashi, not always. In fact, if you look at the literature, go through the literature on the structural evolution of this terrain, most of them are unanimous that the deformation perhaps started with the northwest-southeast crustal shortening, but then it progressed to a stage of transpression. So naturally, there is an oblique shearing associated with that. So some of the loads are actually located along those tensional areas, and then deformation continued. So the sections which I have shown are actually picked up from different areas to highlight the structural control at various scales in the overall terrain, but at the mine scale, it is not always the thrust planes, but there are also other, like in some cases it could be a fold hinge, or in some cases it could be a tension gash, or that type of setup where the mineralization is located. So it varies from place to place, but definitely the regional structure, the strong crustal shortening which has happened at the early stage of the deformation has a significant impact in the major structures developed in the mines.
Thank you, sir. Thank you, sir.
Thank you, sir. There is there are a couple of questions in the chat box, and a couple of questions,
Okay.
more than a couple of questions.
Okay.
First is from Shubha Roy. The question is, Dharwar Craton is juxtaposed with southern granite terrain, but probability of appearance of gold in greenstone belt of Dharwar is more than granitic terrain of south of India. What is the reason? Then the second part of this question is, may metamorphism affects the gold mineralization? And in addition to that, in addition to that, there is another question attached to it, is how gold is associated with BIF, syn depositional or post deposition?
Okay. Let me take the questions one by one. The first question about Dharwar Craton and granulite belt. These are essentially, although spatially juxtaposed with each other, they are two different crustal levels. One is a greenstone belt, which is one is a terrain with a number of greenstone belts juxtaposed against a deep crustal belt with an amphibolite facies transition zone in between. So the granular terrain is actually exposing a deep crustal belt. So most of the gold mineralization, what we see, are all related to the greenstone belts, Archean greenstone belts in the Dharwar Craton. What was this other question? The other question was banded iron formations. See, banded iron formation related to gold mineralization, you can see that there are some cases where sulfide banded iron formation is a rock which gets, which has various facies, like, you can have silicate facies, you can have sulfide facies. So when it is sulfide facies, there are some cases where syngenetic gold occurs along with it. But what actually hosts the major BIF hosted gold mineralization is actually the ability of the gold to get deposited in an iron-rich situation, iron-rich host rock. That is exactly the reason why you get gold in metabasalt or in banded iron formation. So just like carbon allows gold to get reduced from the solutions, so carbonaceous phyllite is, you will see, associated with many gold deposits. So in a similar way, iron-rich rocks also host gold. And It depends now. Most of the better known gold bearing VIFs are actually related to the fact that the sequence in which banded formation is present is deformed, metamorphosed, and gold bearing lodes emplaced by gold bearing lodes. And because of the peculiar iron-rich nature of the host rock, gold gets deposited there. That is what normally we see.
Devarajan sir, just for clarification, can I ask you a question about BIF?
Please.
This is really a very complex thing, you know, in terms of understanding, you know, gold and iron, or BIF or the iron in general. I think that two different things comes to people's mind. One is the IOCG, which is entirely different.
Yes, yes, they were entirely different. Yeah.
Right, and that I have seen in different forums, people combine those things. It gets messy discussion. It doesn't become a geological discussion. But I think what you were saying, sir, this is a question. Kind of clarify, actually, sir. Correct me if I'm wrong. I believe what you were saying is BIF just becomes a host rock, right? When you see the iron, but iron, sorry, the gold occurs actually in the probably the fracture planes or other things.
Right.
But BIF just hosts, right? But the minerals in BIF probably doesn't have much to do with the gold coming into the system. Is that right?
Right. Yes,
Okay.
exactly. In most cases, two recent deposits where I have spent some time. One is the Ganajur gold deposit where Geomysore and Deccan Gold has explored in Karnataka. And another is the Mylappaly as part of the Kolar. In both cases, if you look at the bulk of the gold mineralization is there are sulfides along parallel to the bedding planes, but bulk of the gold mineralization is actually epigenetic or later. In fact, in Mylappaly, there is a fold hinge and fold hinge developed with the form surface of bedding planes of banded formation, but bulk of the gold mineralization is along the axial plane, cutting across the hinge. So that clearly shows that the gold mineralization in Mylappaly is, although it is hosted in a banded formation, it's actually controlled by the structure. So BAF is just a host of them.
Hello, sir.
Yes.
Hello, sir. Yes, sir. Sir,
Yes, yes, please.
any metamorphism affect any gold mineralization
please
for granulate?
Please
Sir,
identify yourself.
Sir, Shubho Roy, sir, JSI Chennai, sir, Geological Survey of India.
Okay.
So,
Okay.
sir, I asked the question, sir, Dharwad Craton and Southern Granulate Terrain, sir. So, metamorphism affect any gold mineralization, sir, for Southern Granulate Terrain, because you told that Mylappaly, that is also the Adakonda belt, that is Kolar Cyst belt extension, which propagates to in the southern part of Tamil Nadu. So say any mineralization is affected by metamorphism. This granitic.
You see, in southern granular terrain, part of the southern granular terrain, you have the Attapadi gold belt, where some of the banded formations also have gold, right? And that is explored by GSI, and you can see the literature. There is that is a part of the granular terrain. So it so happened that the rocks have undergone higher grade of metamorphism there. That's it.
Thank you, sir.
Thank you, Shubha. There is another question from Jain Das. Any early Proterozoic gold occurrences in India?
You see, the Paleoproterozoic belts in India, we have the classical example is Mahakasha belt itself. As we mentioned, Mahakasha is a Paleoproterozoic belt, which also has almost similar geology as the Birimian belt of West Africa. In fact, if you look at the reconstructions of Colombian supercontinent, a supercontinent which existed between around 1.8 to 1.5 giganum, in that, if you see some of the reconstructions of that supercontinent, India is just opposed, adjacent to West Africa. So West Africa is, you know, that West Africa is just before Atlantic Ocean was opened. West African Craton and the Guyana Craton were together. This is the Guyana, Suriname Craton and West African Craton were together. So the Suriname Guyana gold mineralization is in the same Birimian Paleoproterozoic belt, similarly laterite covered areas, and that continent you extend further and take it back to 1.5, 1.8 to 1.5 giganum, you reach the supercontinent which existed at that time, which is Colombia. And Colombia had Colombia also had India as its one of the components. So Mahakoshal to Birimian, the stratigraphic, lithostratigraphic correlation, that is something which we have not clearly understood. As I have mentioned, if you look at the Birimian stratigraphy, you have a lower, I am not, they have called it as a lower, but let us say now they are all tectonized, so the contacts are not very well clear. But you have belts which are rich in volcanic rocks with limited metasediments juxtaposed against sedimentary rich belts, so they call it them as basins. So basins and belts. Now look at the stratigraphy of Mahakoshal. It's almost similar. You have a lower sequence of volcano sedimentary sequence with sediments are less, which we call as the Agori and Parsoi formations and Agori formation. And the upper part of Mahakoshal is an area of thick sequence of turbidites, phyllites, quartz wikes, and gravakes, where Kashi had worked along with me in the past. So there, the sequence is almost like what the Birimian geologists call as the basins. Okay, so the basins of essentially sediment-rich sequence of Birimian belt are almost similar to the Parsoi formation in Mahakoshal. And the Parsoi formation host gold mineralization like Gurhar Pahad in India, and its further extension, a number of other wells, occurrences in UP and MP. But we have not been able to convert these or take up these into the level of mine because of perhaps the grades are not good enough or the resource is not good enough in terms of tonnage. But definitely there are indications, as Jayan Das has asked. There are similar gold-bearing occurrences in Paleoproterozoic belts in India.
I think Kashi sir wants to add something on it.
Yeah, yes, Kashi,
Yeah.
please go ahead.
Sir, no, sir. Actually, that's what you already explained. When you mention Mahakoshal, I also become interested to listen. So you already explained. So that's what my thinking is, that in Mali, there are so many gold mines which you have shown. Mahakoshal, yes, we both worked. You guided me to a lot to learn that part, but that much of grade is not there. That's what I just thought to ask.
Yes, Kashi. Unfortunately, that is the reality. But the level of exploration, maybe whether we have done that type of exploration like what is being done in this country, in spite of the laterite cover, which I have shown, that is another question which we need to ask.
There's another question from Narasimha Rao sir. What is the average grade or concentration of gold in greenstone hosted deposits, paleoplacers, and production mines? Also, what are the sulfides associated with the gold in this region? I believe you're talking about the region of Western Africa because that is the context, or it is about India.
It is difficult to say because it varies. The average grades varies from belt to belt and mine to mine. But yeah, I am not able to answer that question because it varies from mine to mine. And the fact that these mines are working with profit shows, there is the cutoff is like I have Dr. Abani here. He is the right person to say what defines an economic cutoff. So these mines are all working with profit, making profit for making millions of ounces of gold. So they are all significant grades are available in these mines. But when you discuss about the average grades in places, there are other issues in evaluating the average grade in places. Dr. Abani will be able to highlight because that is the maximum variance will be seen in the places, even the paleo places, but it varies. So these are all small scale operations, the placer deposit mines, for the same reason of unpredictability of the grades within the places. But there are many people who are working on that as well.
Thank you, sir. I think we are now already over time. So thank you very much for your presentation today. And if there for the participants, if there are still more questions, please you can write to us also. We will patch you with sir, and we can take it forward from there. And thank you, sir, for this wonderful presentation, and thank you all the participants for attending this. Now for next session, please do continue to visit our site for the update on coming sessions. Our next session will be delivered by another great economic geologist of India, Mr. Dr. Vasudevan, sir. So I believe you all will be also registering for that session as well. Thank you, everyone, and thank you, sir. Thank you, Abani, sir. Thank you, Kashi, sir, for interacting so much and making it live. And thank you, everyone. Thank you for participating.
Thank you all.
Thank you, sir. Thank you, sir. Thank you.